Hello everyone, my name is Christian Raymondez. In this video, we will be discussing all about the random variables, which includes the discrete and continuous variables as well as the levels of measurement. So before anything else, let us discuss first what are the levels of measurement. So the levels of measurement is about how each variable is measured, whether qualitative or quantitative, and how precise each variable is. This is where the variables are being collected in the most precise and informative way. So the levels of measurement have four categories, namely the nominal, ordinal, interval, and the ratio. So let's talk about first what is the nominal. Okay, so what is the nominal? So the nominal is the least precise and informative because it only names the characteristics or the identity we are interested. So for example, you're interested in knowing the sex of your respondents. Typically, there are only two categories, which is the man and the woman. So let's say that you could mark a male respondent as 1 and a female respondent as 0. Now, when it comes to the sex variable, now if respondent Jenny or whoever it is was marked as 0, so that means that respondent's sex is female. So that is also another thing to the male respondent. So of course, nominal measurement also have lots of examples, more likely names, geographic location, zip code, partisanships, and also a political affiliation or the public affiliation. Now let's move on to another levels of measurement, which is the ordinal measurement. Now in ordinal measurement, the value stress the order or rank of the value, but the differences between each one is not really known. Like for example, you might consider yourself in the middle class, but how much better off are you compared to a friend of yours who identified him or herself as a lower class? Or in ordinal variable, the numerical values name the attribute or characteristics, but also allow us to place the categories in a natural and reasonable order. That is what the ordinal variables or the ordinal measurement tells about. Ordinal measurement also involves a lot of examples, like for example, the Likert scale, which contained the strongly disagree, agree, strongly agree. And then another one is the class standing, which is the freshman, sophomore, junior, and the senior. Another one is the socioeconomic standing, which is identified in such a lower, middle, and the upper class. And then the last one is the quality or democracy, which includes the very high, medium, low, and then very low.
To continue the discussion of the remaining categories of the level of measurements, I am Niza O. Navarro, who will be the one to discuss further about the interval and ratio level of measurements. So let's begin with interval level of measurements. Interval is defined as a numerical scale where the order of the variables that have familiar, constant, and computable differences are classified using the interval. In addition, it ranks data, and precise differences between units of measures do exist. However, there is no meaningful zero. For examples, IQ, scores, and temperatures. For instance, let's consider a Celsius or Fahrenheit temperature scale like 80 degrees is always higher than 50 degrees, and the difference between these two temperatures is the same as the difference between 70 degrees and 40 degrees. Also, the value of 0 is arbitrary because negative values of temperature do exist, which makes the Celsius or Fahrenheit temperature a classic example of an interval. So next is ratio level of measurement. It is defined as a variable measurement that not only produces the order of variables but also makes the difference between two variables known along with information and the value of true zero. Moreover, ratio possesses all the characteristic of interval measurement, and there is a true zero exists. In addition, true ratios exist when the same variable is measured on two different members of the population. For examples, height, weight, time, salary, and age. So that's all for the discussion for the level of measurements. Hope you learned a lot about this lesson.
Hello, my name is Mary Rafaela Estumata and I'm your tackler, and at this moment we will tackle about discrete variable. But first, let's know what variable is. Okay, so what is variable? Variable is a characteristic or attribute that can assume different values. Variables that are associated with probabilities is what they called random variables. So, random variables can be discrete or continuous. So, here it is. Discrete random variable have a countable numbers of outcomes. So, for example, number of sales. So, it's discrete. Number of calls. It's obviously discrete. Share of stocks. It could be discrete because when you talk about share of stocks, it should be a whole number. Let's say I have 10 stocks in the market. Okay. And the last example is mistakes. We can count for example, the mistakes of a test paper.
Good day, I am Shalamay A. Hinpit. In this video lesson, I will discuss about the continuous random variables. There are two types of random variables. Those are discrete variables and continuous variables. Continuous variable. Continuous variable is a variable which can assume any of an infinite number of values or can be associated with points on a continuous interval. For example, weight, height, volume, and etc. I will give you an example. Amount of sugar in a milk. We can say it is continuous random variable because it has an estimated amount. For example, 1 tablespoon of sugar. But we don't know how many sugar in a tablespoon. And now, please get a piece of paper or notebook and ball pen so that you can join with me. I will give 5 items and you will classify if it is a discrete or continuous random variables. Okay? Are you ready? Let's start. Number 1. Time to finish running 100 meter. Okay, it is continuous variable because it represents measured data from time. And for you to easy to remember, when we say discrete random variables, those are countable values like 1, 2, 3, 4, 5, and so on. And when we say continuous random variables, those are measurable values like decimals 1.2, 3.5, 1.21. Okay, let's proceed to the next number. Number 2. Outcomes in a flipping a coin. Yes, you're right. It is discrete. Number 3. The speed of a car. Okay, it is continuous. Number 4. The time needed to finish the test. Okay, it is continuous. And lastly, number 5. The number of eggs a hen lays. As simple as that, it is discrete because it is countable. Let me end this video with a saying. Life is a math equation. In order to gain most, you have to know how to convert negatives into positives.